here. Okay. Can you hear me well? Okay, I can see my... Perfect. So first, thank Julian for the interesting talk. My name is Rotem. I'm from Algorand, the Director of Product Management. And today, I'm going to talk about Algorand state proofs, which in my mind is one of the most important features Algorand has ever released. Well, actually, to be correct, very soon to release. And let me tell you a bit about it. So let's start with the things we know. So blockchains are great. I mean, this is why we're here. They brought us this amazing P2P transfer network that is decentralized, secure, very low cost, and also readily available whenever we need them. So that's why we're here. I just didn't say anything new. But the thing is, they are walled gardens. So all the great things I just mentioned are kind of close to the ecosystem of the blockchain you're in. So if you're on Ethereum, or if you're on Algorand, if you're on a Bitcoin, you're just locked to this specific ecosystem. And the other thing is that you cannot easily, nor trustlessly, transact with other blockchains or with any other entities. So for example, if you want to trade ETH and Algo, one for each other, you cannot just do that easily. If you have USDT on both networks and you want to transfer them from one to another, that's not an easy task. And the other problem is that composability, or I should say the lack of. It's really difficult today, and I should say pretty much impossible to create a dApp that is built on top of more than one blockchain. If you know how to do it properly, please meet me after that, because I'll be really happy to know. And the last thing is that it slows down the adoption of the traditional financial institutions, which we want them to join the party. And for example, one of the problems there is that banks will adopt blockchain at some point. They will have no other way around it. And think of the fact that they will not be able to communicate with each other. So for example, think about it today that you have a bank account in, let's say, Chase, which is a very popular American bank, and you want to transfer $100 to your friend, and you're on another one, and the bank tells you, no, sorry, it's impossible. We can't communicate with them. So that's not great. So what do people do? Because we do transfer things. And we know today that most of the transactions, the off-chain transactions, happen outside the blockchain. And it happens by centralized entities. And it's an issue because it introduces risk, significantly higher latency, and also much higher cost. And this is really not what we came here for. This is not the feature we want. And we really want to change that. So we just don't like the middlemen. And it's kind of absurd because we came from a decentralized space, and we're really going again to a centralized one. So what do we want to do? We really want to get the system, a generalized one, that will allow interoperability between different blockchains, and we want to have it completely trustlessly, and we want it to be efficient. So the guy in the middle, we don't want him. This is out of the game. So we want to get to the situation where blockchains can talk to TradFi institutions, can talk to DeFi apps, can talk to Web3, when these are going to be significantly more prominent. And we want all of that to be very seamlessly, and we want it to be the same way we do it within a specific blockchain. This is really what we want to do. So once we have it, what can we do with it? So we can really build bridges, and they can be trustless. We can also create these dApps I just talked about, and blockchain developers can make it significantly more blockchain agnostic. And also, we can connect to any other entity. It's really going to be as simple as possible. Other institutions do not need to understand blockchain as much as they need to understand it today. And really just have a significantly better user experience. In the space for, I don't know, about 6-7 years now. And it's kind of bugs me that I still cannot just transfer at once basically multiple tokens. Why can't I just again send this ETH and Algo together in one transaction and make it easy? So let's talk about a second how we're going to do it, because clearly I'm here for a reason. And I'll put a small disclaimer. The next few slides are going to be a bit more technical, not too much. So if it's not for you, it's OK. You can go to sleep. I promise to wake you up after. But there are very specific 3 points that I want you to take out of it without listening to the entire spiel that I have, is that state proofs are essentially a compressed set of signatures that attest to a specific event on a blockchain. The Algorand blockchain produces them frequently, and that attests essentially to a block. And the most important part is that an external application can use these to really verify actions on the Algorand blockchain. So what are actions? So essentially, you can think of it as transactions, balances, smart contract states, etc. So let's talk about it. First thing first, like everything that Algorand does and every other technology, these things are backed with serious literature, like research, peer-reviewed, and this one is not any different. So the Algorand state proofs are essentially based on a paper that came out of our research team together with leading universities like MIT, Brown, Stanford, and Boston University. It was published earlier this year in IEEE, and there's going to be a link in the slides for you who want to dive deeper later on. So now let's talk about how we actually use it. And we're going to do it in 3 steps. And essentially, I'm going to walk you through the example of how we're going to build a bridge. So let's talk about the first thing, is that how do we generate a state proof? So it's going to happen in 4 steps. We're going to talk about how we're going to generate a state proof of round x. So the story actually begins a bit earlier in round x minus n. N is just the interval. Think of it as like a number of blocks, let's say 128. In Algorand is about 10 minutes. And at this round, the network essentially commits to a set of participants that are going to attest to the block that's going to show up a bit later. Fast forward 128 rounds. Round x is being produced. We're all happy. And now starts the phase of attesting. What happens now? Essentially, all the accounts that got announced 128 rounds ago are now starting to sign the messages of saying, hey, I seen this block. This is a real thing. There you go. And they start propagating through the network. Now, for those who are curious why it's like a bit long one, why it's like 64 rounds, it's really just because we don't want to spike the network with an absurdly large, basically bandwidth. So we kind of like want to spread it around. That's really the only reason. Then at that point, the relays, which are like core of the Algorand network, essentially collecting and aggregating the signatures and producing a state proof the moment they passed a specific threshold. The moment we have that, they ship it to the network. That happens, that basically shows up as a transaction, a normal transaction like anything else, and we're done. Now, when we have these like state proofs, we need to understand the important part is that it really enables us to create a light client outside the Algorand blockchain. So essentially, you can think of it as just any other website or on a smart contract. So now, when we want to build this like bridge, we need really to sync the states of the 2 blockchains. So on the left, we can see Algorand, which, as I said before, has this like list of state proofs. And on the right, we're going to have a random blockchain that supports smart contracts. Let's call it Y. And essentially, this blockchain is going to have the light client as a set of smart contracts. And in between, we're going to have a state sync application. Now, this is off-chain. It doesn't need to be trusted, because you cannot forge the state proofs, and you cannot convince anyone. You cannot prove a fault one. So essentially, we don't really care who does that. Just anytime someone do it. And now, when we have this like thing, when this like light client essentially gets updated on the other chain, we can answer questions like, hey, has this transaction on Algorand occurred? Hey, has this account A in balance B, in round R had a specific balance B? Is that a case? Yes or no? And this thing like can be like very useful, and we're going to see it in a second. So now, when we actually have this light client, and we can answer these questions, we can build a bridge. Now, I know there are pretty much gazillion and one ways to create bridges, but I'm going to talk about probably the most common way to do that. And when we have a bridge, is really our intention is to move assets usually from the same kind, from one blockchain to another. So let's say that we want to transfer USDT that we have on both chains. What happened now? So again, on the Algorand blockchain, we're going to send our, let's say, 100 USDT to this special account that the bridge maintainer is designated. And from the bridge point of view, what the bridge needs to see is that this thing happened in order to release the funds on the other network. So now when we go to the other network, which now has the state of the Algorand chain, we really can just be like, hey, is this transaction happened? And if the answer is yes, we can release the funds. And we know that this thing can happen in a decentralized fashion. And the bridge maintainers basically have nothing to do with it. And the nice thing about it, and it's trustless, this is like, that's why we call it like that, because the bridge maintainers basically have nothing to do with the verification of these transactions. It's not up to them, and even if tomorrow they're gone, a user can really go and just be like, hey, this is the proof I did it, please send it to me through a smart contract. And we're good there. Okay, we leveraged a couple new crypto primitives in this one. The first one is subset sum hash. Now, for those who are like very well versed in the areas of hashes, it's not a real hash. It like satisfies 2 out of 3 properties, but we're still gonna call it a hash because it's like easy and useful, and it's very snark friendly. And the other one is Falcon. Falcon is a new signature scheme that's also post-quantum resilient, and we're gonna talk about it in a second. Both of these, the implementations, et cetera, are available online in our repos, and you can find it there. Now, just for reference, for after that, the slide's going to be available online for those who want to learn more, because clearly I just scratched the surface and nothing else. There is a list of reading that you can go through. All right, done with the technical part. Let's talk about post-quantum security. The known, it's a problem. The current crypto systems that we use, the cryptographic systems, whether it's the elliptic curves, and no matter which one of them we use, they're basically broken once we have strong quantum computers. So that's the thing. The when we have that, it's pretty bad, and the entire like blockchain system basically gonna collapse. But okay, it's not that dramatic. We can do things against it. The complicated part, it's not that easy to defend against it. Because cryptography is really in the guts of the system, it requires pretty invasive changes and intervention in the blockchains, and we need to find ways around it. And the other thing, which is not a technical problem, but it's really more of like a business one or like a maybe psychological one, is that it's a problem of the future, right? Like we don't know when strong quantum computer is going to be here. We hear things about like 5 years, 10 years, but we really don't know when it's going to happen. And it's hard to make the investment in a sense of like, oh, I'm just going to invest in it right now, even though it might not be relevant for the next 20 years. But the issue with this argument is that once you learn about it, it's already too late. We won't be able, like, if we hear about that, it means that probably some institutions or some people already gained the power to break the cryptographic systems and to transfer money and to make things pretty bad. So why am I telling you all of it? In Algorand, we've been thinking for a while really about how we're going to approach it, because we really want to be ready for this thing when it happens. And we're not here for the next 2 years. We plan to be here pretty much forever. And then we have a full roadmap that we are going to publish soon about how we're going to achieve it. But the first step is really to defend the history. So essentially, right now, what we can do in a non-invasive way to make sure that the data is protected and no one can change the history of the blockchain once quantum computers are here. And you just heard about a solution. It's called state proofs. And really, I'm super proud to say that like with state proofs, Algorand is the very first blockchain to provide you with post-quantum security. And your information is going to be saved there pretty much forever. And this is really just like the very first step, and we're going to hear more about it very, very soon. Now, let's talk a bit about the road ahead, what else we're going to do. So now once we have this like state proofs, we're going to integrate them into our catch-up process. So essentially, you know that when you catch up with a network, you're not going to get any false blocks, and you know that you're always getting the right thing. The second thing is that, as I said, we really try to make it cheap and efficient, but we want to make it even cheaper and even more efficient. And by that, because, for example, Ethereum price, last time I checked, didn't really go down. It keeps rising. And using the smart contracts there, it doesn't get any cheaper. So we are snarking the state proofs. We're using zero-knowledge proof essentially to create a very small proof. I'm going to make it super efficient for you to use. And the last thing, we're going to release a set of light clients and essentially ready-to-be-used tools to make every developer life much, much easier. And basically, that we're going to do all the heavy lifting, and you can just like use it very easily. That's going to be it. Thank you very much for listening, and also thank you very much for those online or watching right now. And questions, if anyone has. Thank you.
I think I can, without microphone, first question about light client. Why not to use, for example, IBC module from the Cosmos SDK that's already created to connect with other chains? Or, for example, don't use parachains from the Polkadot. And the second question is about keeping the data. Why don't use IPFS? Even if the quantum computer will be created, they can't delete nothing from the IPFS. Nobody can delete nothing from the IPFS.
I start with the last part. So I'm not too familiar, to be honest, with like the deep tech behind IPFS, but unless they're using quantum resilient, basically cryptography, it's going to be broken. You'll be able to change the history by like essentially convincing, like changing the chain and like building an alternative one. But again, I'm not too well versed in that, so I cannot give you like a precise answer there. And why not to use other solutions? So there are different ways to implement essentially the interoperability, like how do you take information out. And the problem with other solutions that has usually a set of verifiers is that, again, you created a middleman. You need to trust these people, and the problem is that you can, if there is a large amount enough of money to be transferred, their incentives might be broken at this point, and actually to make sure to verify the chain properly, and they might just lie. Now, with this solution, there is no need to trust any other set. Like, this solution is as secure as the network itself. So if you trust the Algorand network, you should trust this solution. Every one of them have different trade-offs, but that's kind of like the main thing. We really try to kill the middleman, a new set of verifiers, and nothing else.
Just IBC module on Cosmos SDK, it's the same. It just means like it's like a ERC standard, just for making not tokens, but the blockchain. If one chain have IBC module and another chain, it's just like the connection port. Get out any third party. You don't need to trust to nobody. Just on the one side, it's frozen. On another side, it's minted. It comes back. It's burning here, created here, and that's all.
Yeah, I think that this is going to become like super technical. We can take it offline, like chat about it. Happy to. Any more questions? All right. Thanks a lot.